Cathal Somers.
And I'm Deirdre Glenn,
your Teagasc Sustainability Advisors.
And you're welcome to the Teagasc Environment Edge podcast number 46, bringing you the latest information, science and opinion to improve farm sustainability. With a lot of discussion around ammonia emissions lately, the use of slurry additives often comes up in conversation, but are they ticking all the boxes? Dr. Dominika Krol, Teagasc Research Officer in the area of agricultural gaseous emissions, joins us to discuss.
Dominika, you're very welcome to the show.
Thank you very much for having me, Cathal.
I suppose, Dominika, the first thing, there's lots of slurry in the tanks there at the moment. We're in January. A lot of farmers wondering about slurry additives at the moment and what they can do for us in the tank. But first things first, I suppose, you'll focus a lot on ammonia and emissions from slurry tanks. Can you tell me a little bit what is ammonia first and why should we be concerned about it?
Ammonia is a gaseous form of nitrogen, okay? And as such is it is a loss of nitrogen from the farm. So what it means is whenever there is slurry spread or synthetic fertilizer applied to the soil, there is ammonia emission associated with it. So that's basically nitrogen being volatilized into the air. So on one hand, it's a financial loss to a farmer. It's also a loss of nutrient, that could be utilized on the farm. But at the same time, ammonia is also an air pollutant and it causes a host of different problems. So as an air pollutant, it has environmental and health implications. So on the environmental side, it redeposits and causes eutrophication. So that affects ecosystems and biodiversity loss. It can also have very negative impact on peatlands that are storing carbon. So it might actually hamper that carbon sequestration in peat soils. Then it can cause water quality issues down the line. It can also lead to indirectly to emissions of greenhouse gas, nitrous oxide, and that's a potent greenhouse gas. So unfortunately, ammonia in itself is not benign, and there's a whole host of different kind of negative implications associated with it. So I suppose that's first and foremost why we're interested in it and why we want to reduce ammonia emissions. And because of those negative impacts on environment and on health, there's legislation to reduce ammonia emissions, and Ireland is bound to reduce emissions by 1%. In comparison to a reference year of 2005, and that's to reduce emissions by 2030. Okay, and from 2030 onwards, we've a target of a 5% reduction when compared to 2005. So you would maybe think that 1% or 5%, it doesn't sound like a lot, but it's actually very challenging target to achieve for agriculture, because ammonia is an agricultural issue. So virtually all ammonia in Ireland is produced from agricultural sources. So really that's where we need to take a lead on reducing emissions here.
Just on the ammonia side of the house, obviously it's a bit of a problem because we're starting talking about it a lot, but you've mentioned environmental impact, and sometimes I'd say to farmers, you can see, isn't it like a slime sometimes on trees that looks like when ammonia hits the trees and it can attach to it. But I've heard a doctor on the radio there last year talking about the health implications when ammonia mixes with other gases over cities. Is that correct?
Yes, absolutely. So ammonia can bind in the air with particulate matter. So especially in cities, if there are exhaust gases and particles from traffic from other sources, that can cause really severe issues in terms of respiratory problems for people. So ammonia binds with those particles, and those then compound particles entering lungs they can cause respiratory problems, to the point where there can be serious health conditions and even deaths associated with with air pollution, and ammonia contributes to that.
And you mentioned that, I suppose, in Ireland, unfortunately, agriculture is responsible for the bulk of the ammonia emissions. What are the main activities on the farm that are responsible?
So ammonia is predominantly associated with livestock agriculture. So unfortunately, we're kind of at the forefront here because of our agricultural systems are primarily livestock based. So we're talking about sources such as animal housing, then and consequently animal excreta deposited during housing. Then that excreta is then moved into manure storage, be it either as slurry or as solid manure. So manure storage is another source, and then manure spreading is a further source. Meaning that what we call this a manure management cascade, from housing through storage to land spreading, and at each step of that manure management chain there can be ammonia emissions from those different sources. So unfortunately, it's not that we lose ammonia in one part of that chain and that's it. It's a problem that keeps on repeating, and at the same time losing farmer more and more nitrogen from the system. The other sources then are animal grazing, so the excreta deposited at pasture, and finally synthetic fertilizers applied to soils. And just to give you a context of how important those livestock related sources are, approximately 90% of all ammonia comes from that manure management, coming from housing, storage and land spreading, and also grazing animals. It's only really 10% that is associated with synthetic fertilizer. And on that side of house, it really depends on the type of fertilizer we're looking at. So they're not all equal. So there is a difference between CAN, straight urea, and protected urea, and that's really why protected urea comes in on stream in the last few years, and and we consider it a really potent mitigation measure. But that's that's where the ammonia comes from in terms of sources on the farm.
Yeah, thankfully, lots of farmers are putting their shoulder to the wheel in regards to protected urea. I've really seen it's noticeable how many more people are using it in the last couple of years, and low emission spreading as well, which is very good with the trail and shoe. I suppose the one thing that's standing out now is we have it in the tanks. How do we stop it coming out of the tank? And a question I would have for you, I suppose, is what is the process in the tank? What's happening that ammonia gets lost? Or sometimes you would think if the nitrogen's in the tank, it'll stay there, but there must be something going on in the tank to release that ammonia or ammonia.
Yes, so look, there are different forms of nitrogen in the slurry. So nitrogen is one of the most versatile kind of chemicals in the world in terms of a variety of different compounds and phases that it can be encountered in the environment. So it is really fascinating. But there's only certain forms that we typically work with. So in slurry, for example, there is a mixture of organic nitrogen and inorganic, or what we also call mineral nitrogen. And the organic form came mostly from the dung side of animal excreta, and that's a much more stable nitrogen. That's nitrogen that when applied to soil kind of gets converted to mineral nitrogen over longer periods of time and becomes available for plant growth. However, that part that's already in the mineral form, that comes primarily from animal urine, and there is a very quick conversion of any organic part of nitrogen from urine into mineral. And that mineral nitrogen is literally one step away from ammonia. So it's called ammonium. And ammonium, depending on pH of the slurry, can very easily convert into ammonia. So the higher the slurry pH, the more of ammonium that can convert it into ammonia. And then ammonia can very easily be lost from slurry in storage. So what happens is it's a very physical process. So it's like evaporation, and ammonia, gets to the surface, and then any wind, the more wind there is over slurry, the more air movement, that ammonia that gets kind of moved away, pushed out, and then more ammonia can come out again. So, for example, when we talk about one of the mitigation option being to cover slurry store, it's literally to hamper that gas exchange so that that ammonia stays within the slurry or just above the slurry, but there is no emission and removing of that ammonia from above the slurry surface that would cause more and more emissions coming off the slurry.
Oh, so that the actual ammonia on the top almost acts like a trap for future ammonia to be produced, then I presume. That's
Yeah, so it's like a chemical
yeah.
balance, in terms of if there already is a lot of ammonia in the air just above the slurry versus what's in the slurry, it kind of it equilibrates. But if you remove that ammonia layer from above the slurry with wind, then there will be more ammonia from the slurry moving into that layer above the slurry, basically trying to equilibrate again.
Yeah, and you mentioned covers, and that's a physical one that we can do. I suppose if we want to get to the root cause of the problem and maybe to be able to treat the slurry in some way, there's a lot of talk about slurry amendments, and I know there's a number of different type amendments. I mean, I think you mentioned there a second ago about the pH, so chemical is one. Can you talk us through the different types of amendments that are being looked at, or maybe they're on the market at the moment?
There's a few different types, Cathal, and I suppose they're at a different level of how advanced the research is, and whether they're already commercially available. So I would classify them kind of broadly as chemical amendments, biological amendments, and physical amendments. Okay, and chemical amendments are probably the most kind of tried and tested. So they predominantly reduce slurry pH, and in that way kind of keeping ammonia in that ammonium form. And to reduce the pH, really the chemicals that we need are acids. So that type of amendments, that's what's called acidification. It's not really broadly available in Ireland. It is already very popular in Denmark, both in storage of slurry, and there's more equipment now being available to acidify slurry in the tanker during spreading. So the technology is much more mature in other countries than it is in Ireland. And that particular technology has a really good efficacy in reducing ammonia. We're talking about even over 90% reduction in ammonia emissions. So that's massive. And that can be done, that's reductions in storage. And then also at land spreading if that slurry still has a lower pH. And I suppose maybe, as a side comment, people would often worry about the impact of that lower pH slurry on the soil. We're not talking about anything very acidic. In storage, slurry is usually acidified to a pH of 5.5. And if it's at land spreading, it's at 6 or even a little bit above the 6 units. Meaning that, with regards to how much slurry is being spread, it's not going to make a huge difference to the actual soil pH, to affect the soil pH so much that that the soil pH is being reduced. But that's on the chemical amendment side. So acids can be, can be inorganic strong acids such as sulfuric acid. That is probably the most commonly used in other countries and in research. Then the second type of, or the second kind of pillar of amendments would be biological amendments. And here there's also kind of a wide range of products that is already available on the market. So they are predominantly based on bacteria or enzymes that are supposed to break down organic nitrogen in the slurry to bring it into mineral form. To be honest, while they're available on the market, there's still quite a lot of research ongoing in that area. And I would kind of advise caution here, because from research of our group, we haven't necessarily seen any reductions in ammonia emissions. So I think there needs to be more research in that area. However, I know from anecdotal evidence talking to farmers, about benefits such as easier agitation or more nitrogen availability, and they might see better yields response. I suppose from my perspective, I'm a gaseous emissions researcher, so my first port of call would be to check whether there is any reduction in ammonia emissions, or it might be also greenhouse gas emissions associated with that slurry. If there is, then we can take that formulation for further testing. But if there isn't, I suppose that's where my role ends. As much as it would be very interesting to pursue other avenues and look at other potential impacts those type of amendments have.
I suppose on that, if you're not seeing, I suppose, ammonia being reduced with that type of amendment, it's a loss of nitrogen no matter what way you look at it.
Exactly, and that's why I remain a little bit skeptical of what exactly happens in slurry, that we don't see ammonia reduction, and some farmers report improved yields. So my thinking on this is because some of those products claim to increase mineralization of organic nitrogen, it's probably that fraction of nitrogen that normally is available over a number of months or even more than one season. If that becomes more available over a shorter time, that might bring kind of that that shorter term gain in terms of yield. But as you rightly say, if ammonia is not reduced, then we're still talking about that loss of nutrient and about the air pollution still occurring.
One question that often comes up, the aeration systems that bubble slurry, is that a good thing or a bad thing?
Unfortunately, I have to say that so far, any research done internationally points to it being rather negative for ammonia and increasing emissions. And I know that's probably not what farmers want to hear, because I completely take it on board that it's very useful in terms of having the slurry agitated and ready to be used. And, it is obviously, it's very good in terms of health and safety that there's no big gas plume as a result of a point agitation. However, one of the main mitigation options for ammonia, and one of the easiest from slurry storage, is to create a crust. And slurry crust is a natural barrier for ammonia emissions. So, a slurry with crust will produce less ammonia emissions. So anything that breaks down that crust, that's a bit of an issue in terms of ammonia emissions. Now, there is talk about kind of low frequency or low kind of small bubbles aeration. I haven't seen those systems in action, and I haven't been able to find any scientific evidence to say, whether they actually reduce emissions. But I suppose the potential is there if, if the technology can be adjusted, that's great. But at the moment, they're kind of antagonistic.
Yeah, and I interrupted you a little bit. I think you were going to talk about physical amendments as well.
Yeah, so that was the last kind of third type of amendments, and that's basically an amendment that might just absorb ammonia or ammonium onto its surface. So things like biochar that has a large surface area, or other these types of materials. Zeolite is another one. So we've been looking at those as well, Cathal, and there's a huge variability there between the different amendments. Like even just to look at biochar, for example, because there's a lot of interest in that area, because biochar is also a source of carbon. So the question is it good for soil fertility, for carbon sequestration in the soil, and how much can it do for the soils and for farms? So biochar can be produced in different ways. There's different methods, different temperatures, different feedstocks, and depending on all that, there's a lot of variability in the resulting biochar. So I've colleagues who worked with one type of biochar, and I'm now working with another, and we're getting quite a different results. So I think that's something to bear in mind, that even if we're talking about one particular product or compound, it might not always be the same.
Yeah, that's always a problem. I suppose I can put you on the spot a little bit now. I'll leave you alone after this one, but slurry amendments, I suppose they're on the way. They're here in the market already, and from some of the discussions we've had, they're not ticking all the boxes the one available to farmer at the minute. You mentioned, I suppose the acidification one. Is that, in your opinion, the one that's going to hit our market that will tick that ammonia reduction box? And do you see that being the one of the future?
I suppose that's what happened in countries such as Denmark, where the system is very popular. And talking to colleagues in the UK, there's more and more acidification systems coming on stream there as well. So quite possibly that might be something that will become more available into the future. However, there's obviously a kind of a few caveats associated with it, such as health and safety, because we're talking about handling quite corrosive, concentrated
and large
acids.
amounts, I would say, as well, is it?
It is exactly, yeah. So how it's handled in kind of in commercial installations is that there's actually an external company coming in to bring in the acid and kind of install the tank or replenish the acid in the tank, so that it's only the trained personnel. And at the same time, you need a dosing system, and potentially, be it a mixing tank that's an outdoor tank. So there's also health and safety of the animals, that it's not just added directly under the slats, and might affect animals above the slats. So that's just considerations. It doesn't mean that it can't be implemented. It is just kind of caveats associated with it. And look, that would be a really good option in terms of how much ammonia can be reduced from slurry storage. I suppose most of our slurry storage is in underground tanks, in slatted sheds, so that kind of limits what type of mitigation we can do with stored slurry. And look, I think we should be looking towards amendments as one of the option. But we need to be careful that we're not thinking about it as the main or the only mitigation option. As you've mentioned before, protected urea, low emission slurry spreading, or covering stores, they're all very good options. And if we look at the ammonia MAC, in that analysis, 80% of potential mitigation for ammonia came from just low emission slurry spreading and protected urea alone. So those two are are very good ways of reducing ammonia.
Yeah, proven technologies, and they're to be used today or tomorrow when they're available to all farmers. Dominika, I suppose that's all we have time for today, but thanks a million. I really enjoyed the chat, and the information you're after giving us is really beneficial, I think, and lots and lots of farmers will be interested. It's one of the main questions farmers always ask me about slurry and additives, so really appreciate your time today.
Great, thank you very much for having me, Cathal.
That's it for this episode of the Teagasc Environment Edge podcast. Thanks to Dr. Dominika Krol, Teagasc Agricultural Gaseous Emissions Research Officer in Johnson Castle, for joining us on the show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts, as well as Spotify, and for more information, go to the Teagasc website at teagasc.ie. I'm Cathal Somers. Join us next time for the Teagasc Environment Edge podcast, signpost to farm sustainability.